Hello everyone, good evening all of you. I think you guys can hear me now. Can someone respond whether am I audible or not?
Yes, sir, we can hear you.
Okay, thank you. Today I am going to do the lab session 9, the multidimensional arrays. Okay, before going to the multidimensional arrays, let's check the previous exercises, that lab session 8, single dimensional arrays. Okay, did you complete this part, the single dimensional array? Any issues with the 7 questions? I think you guys did this part. Do I need to explain any of these questions in the single dimensional array? 1, 2, 3, 4, up to 7. One student asked the 7th one. Okay. Okay, let's do this 7th question. It's asked that write a C program to find the correlation coefficient R and the regression equation of Y on the X for the N of the 12 values, 12 pair of values, observation of the CPI in the given two subjects X and Y. Okay, you have two arrays called X and Y, and you have to find the correlation and the coefficient. Okay, it is given as R. Give me a minute. Okay. And it is asked the regression equation y on x is y minus y bar equal byx times x minus x bar. I think you already did this kind of statistical analysis in the particular subjects. There's a mathematical subjects available in your semester, no? For this, I think in this semester you have this kind of regression analysis mathematical subject. I don't know what is the subject name. Do you have such kind of one? Correlation coefficient, how to identify? Okay.
Yes, sir.
You have, no? Okay, if you don't know that, I will give you the brief introduction. No need to worry about that very deep words available here, coefficient, correlation, those things. However, you already learned those things. Just what you have to do is there is two arrays available, X and Y. You have to find the correlation regression equation. Okay, regression equation equal Y minus Y bar. I think you know what does it mean by Y bar. Y bar means the mean of Y, mean value. Okay, and the X minus X bar, mean of X value is the X bar, and the BYX. What is the BYX? How to calculate the BYX is available here. Okay, equation is available here. Okay, the regression establishes a linear relationship between X and Y by the data. It helps to predict the unknown Y values for the X values for the input by the user. Okay, so this regression analysis, that this one is help you to identify the unknown values. Okay, that means unknown, that it helps to predict in the unknown Y values for the X value. Okay, that means you can predict. You can predict. That means already given values are available, X values are available, and the Y values are available. Okay, here it is given that when the X is 1, Y should be 3. When the X is 0, Y should be 5. When the X is 3.2, Y should be 0. When the X is 4, Y should be minus 1. Likewise, for the X values, there are several Y values. How many values available? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, that is why it's mentioned as there are 12 values available. Okay, however, you can see there are certain kind of X values available, not for all the X values. 1 available, 2 available, and I think 3 is not there. Okay, then by using this regression analysis, you can predict what will be the Y value for the X equal 3. Okay, here you can see the 3.2 available, 3 is not there. Okay, now we are going to do that. I think better you mute your mic if you are not wish to speak. Satsara GMS, mute your mic. Okay. So now you have this kind of two X and Y values. Okay, what that means by looking at this one, you may think this is very difficult question. Okay, but actually this is the simple questions available. Okay, so this is also one of the mid-semester examination question in the previous batches. Okay, now what you can do is simply apply whatever the data given in the X and Y to this equation and fill this equation. Okay. Okay. First take that here it's take that coefficient R. Okay. Now you have to find the coefficient R. How to find the coefficient R? Here you can see the equation available. How to find the R? R value is equal sigma xy. Okay. What does it mean by xy? Xy means x into y. Sigma means summation. That means let's take here sigma xy mean summation of x multiplied by y. Okay, and there was a question. So can you explain the fifth one as well? So, okay, after this one, let give me a reminder to the fifth one. Okay, now here you have take the summation of x into y. That means here you can see the x. First one is x is 1, y is 1. Okay, you have to multiply 1 into 3. Okay, you know the 1 into 3 is 3. Okay, you have to get the summation. That means plus. And the next one, you have to take the x into y. X into y means x is 0, y is 5. 0 into 5, that is 0. 0 multiplied by 5 is 0. Plus 3.2 into 0, that means it is 0. Plus 4 into minus 1, that means minus 4. Plus 1 into 0.5, that means 0.5. Likewise, you have to get the summation of all x multiplied by values. That is the meaning of this one. Then you have to deduct sigma x. Sigma x means summation of all x values. That means 1 plus 0 plus, that means 1 plus 0 plus 3.2 plus 4 plus likewise. You have to get the summation of all x values. And after that, sigma y values. Get the y values. 3 plus 5 plus 0 plus 3 plus 5 plus 0 plus minus 1. Likewise, get this one. Suppose that there is a value available and here also you have a value and sigma x into sigma y. That means this value multiplied by this one. Let's say this is k value, k1 and this is k2. Then you have to take the k1 multiplied by k2. That is the meaning of this one. And divide by n. N means number of values. How many values are available? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. However, value is given here 12 also. The n is 12. Okay, likewise here. What is this one? Sigma x squared. That means x into x values summation. Okay, now here x value is 1. 1 into 1. That means 1 multiplied by 1. Okay, that is a square. Plus, that means you have to take the summation. Then 0 into 0. 0 into 0. Plus, then 3.2 into 3.2. Okay, likewise, you have to get the summation. Okay, summation of this one. That is sigma x squared. And next one is sigma x whole 1 squared. Sigma x you already taken. Here the sigma x, k1 value. Okay. That means here you have taken the sigma x. No? Sigma x means k1. K1 squared. Okay. Divide by n is 12. You know n value is 12. Likewise, here the y value. Okay. You have to take the calculation. Okay. First let's apply this value to this equation and find the r value. What you have to do, you have to take the OpenCLion IDE. And new project, executable. Okay, now what we have to do is you have to declare two arrays to hold x and y values. Okay. Now this is floating point values. You note that one is integer value, 0 is integer value, but 3.2 is floating point value. Therefore, you have to create floating point array, not an integer array. Okay, floating point array or double array. You can use either one, floating point values or double value. Okay, here let's say double x size is 12. So there are 12 values available. Okay. So since there is n value available, we can use that one. Int n is equal to 12, and here x size is n mean 12. Okay, here you have to assign the values. What is that? Int n has not been initialized. Okay, I'll check and let you know what. Don't know what is that error. Let's say 12. Okay, now assign that 12 values to here. 1, 0, 3.2, 4, 1. 1, 0, 3.2. 1, 0, 3.2. 4, 1, 5, 7. 0, 2, 1.1. -1, 4.1. Okay, then we can declare the second one, double y values. That is also size 12. What are the y values? 3, 5, 0. -1.5. -1, -2, 3. Okay, let me know when I am, if I did any mistake. If I am doing any mistake, let me know. -2, 3. 4, 1, 8.1. 2. Okay. Then what we can do is we have to get these values. Okay, now you know this is our equation. Okay, we have to calculate this equation. Okay, how to calculate? Now you know this is a complex equation. This is a very complex equation. Therefore, we have to uh, do parts one by one. Okay, let's take numerator and denominator. Okay, let's say the upper one is a numerator. You know this is a numerator, and this is denominator. Okay, then what you can do is we have to calculate the xy values. That means summation of x into y value. That means how do we identify that one? Let's take this one as take a variable to identify this one. What should be the better name for this one? This is xy. Let's say this one is xy sum. Okay, let's say xy sum. Put a particular variable for this one, and this one is let's say this is x. This one take as x summation, and this one we can take this one as y summation. Okay. The numerator, numerator is equal xy summation minus summation of x, that means x sum multiplied by this y sum and divide by n. N is 12. Okay, this is our numerator. Okay, let's calculate this one, numerator value. How to get this one? You can write for loop. I equals 0, I less than 12, size is 12, and I plus plus. Okay. Because that we have to go through a proper for loop and get the summation or multiplication or whatever the one. And before the for loop, declare those variables that we have calculated here. So not the calculator, we have declared this kind of variable x, y sum, x sum, y sum, and the numerator, denominator. Let's say double numerator, denominator, num, then numerator, denominator, and x sum, y sum, x, y sum. X sum, y sum, x, y summation. Okay, now what we have to do, we have to get those summation properly. That means take the x summation of x values. Okay, summation of x values available in here. Initially, let's say summation of x is 0. Here we can take x sum is equal existing x sum multiplied by. So if you are not wish to speak, mute your mics. X sum x summation is equal existing x summation plus array I location. That means I initially 0, take the 0th location, add it to the x sum. Initially it is 0, 0 plus 1 is 1. Then take the next value, add it to the here. Likewise, take all the things and put it to this variable. Okay, then you can take the x summation. Then y summation of all y values. Okay, initially summation of y is 0. Then you can use y sum is equal y sum plus y I value. Any questions up to here? If you want, you can use a shortcut way. X sum plus equal xi. Y sum plus equal yi. That is also correct. Okay, now we have calculated our what we call x sum as well as y sum. And next one it does x sum, y sum available. And next one is x into y and summation of that one. You have to multiply x into y. And after that, get the summation. That means x, y sum. Let's take initially it is 0. Then how to calculate the x, y sum? X, y summation is equal existing x, y summation, existing 1 plus you have take 1 multiplied by 3. Summation of 1 multiplied by 3, 0 multiplied by 5, likewise. Okay, now how to get the existing one is 0. First, existing 1 plus x I location multiplied by y I location. I think this one is asked, no? That means I is initially 0, x 0th location, that means 1 multiplied by y 0th location, that is 3. You have to multiply it 1 into 3 and add it to the summation variable. Initially it is 0. You have to take this value. Okay, xi value multiplied by yi value. Any questions up to here? Give me a minute. Okay, sorry for the delay. Okay, now we have the x summation value. That means here we have calculated x summation y value, this one. Okay, now you can calculate the numerator value. Okay, so how to calculate the numerator? After the for loop is finished, you can calculate here. Numerator is equal xy summation minus, that means xy summation. Okay, that means xy summation minus x summation into y summation minus x summation into y summation. X summation into y summation. X summation into y summation divide by n. Okay. X summation into y summation, the whole thing divide by n. N is 12. Okay, here n value is also available. You can use that, divide by n or divide by 12. Okay, however, these brackets are optional because this multiplication available, you can divide by 10. Divide by 10. Okay, that is our n value. Okay, now we have calculated our numerator value. Okay, now we have to calculate the denominator. In the denominator also, it is a little bit, what do you call, complex part. Therefore, we can separate that one according to our needs. Okay, let's say denominator, I will use a different color. Take this one. Okay, here you can see x, summation of x. That means x sum. But here you have take the square root of x, summation of square root of x. Okay, therefore let's declare a variable called x square sum, x sq sum, x square sum, SXQ sum for this one. And this is summation of x square. Summation of x we have already taken. Summation of x, this one, x sum. Okay, now you know this is this x sum squared. Okay, n value you know it is 12. And here you can see the y value. Okay, square root of y and take a summation. Therefore, let's declare a variable y square sum for this one. And minus after that, this part, you know, this is summation of y. Summation of y you already defined here variable y sum. Y sum squared. And this is 12, you already know. Okay, then what you have to do? You have to take the x square sum and minus this value. After that, this one minus this value. And after that, take the square root of this one and take the square root of this one. Okay, after that, multiply that one. Okay, now what we have to do is, before the multiplication, I think it's better that the whole part is the denominator. Let's take, I will use a different color. Take this one. Take this part as den 1 and this part as den 2. Okay, you know that den 1 is equal x square sum minus x sum square divided by n. And take the square root of this one. Okay, we will take the square root of other things later. First calculate the x square sum and y square sum, and x sum is already calculated, y sum is already calculated. Now you have to calculate x square sum and the y square sum. Okay, you can use the same for loop. Okay, it is not required to create another for loop. Same for loop, you can do that one. So define the variables x square sum, square mean let's say SQ, initially 0, and x square sum, this is y square sum. Y square summation, initially it is 0. Okay, now how to calculate x square sum mean x into x and take a summation. Okay, that means x square sum is equal existing x square sum plus, how to get this one? X into x. Okay, that means 1 into 1. After that, 0 into 0. 3.2 into 3.2. Likewise. That means x into x. What happened here? Sorry, not the Excel. You have to use the XI location. That means how to get that one? You have to take the each value, x0 location into x0 location. Okay, now I think you guys can understand. And x0, x1 location and x2 location. Likewise, here I did the mistake. X0 location, that means xi location into xi location. Likewise, you can take the y square sum is equal existing y square sum plus y I value multiplied by y I value. So you can take the square of that value. Okay, now you can calculate that one. You have the square sum and the x sum available. You have to multiply, you have to take this one and divide by n. We call this one is den 1 and this is den 2. Okay, calculate the den 1 and den 2. Take here den 1, den 2. Okay, now you can calculate den 1. Den 1 is equal x square sum, this one, x square sum minus x summation of x here, x sum square. X sum is we already calculated here. X sum is already calculated. So we can use x sum into x sum. Square of that one means x sum into x sum. Okay. X sum into x sum divide by n value. N mean 12. Divide by n. N mean 12. Okay. Since this x sum and y sum, so here I think I did the mistake. No. X sum into x sum divide by n. X sum into x sum divide by n. After that, what we can do, then we will take the square root later. Okay, now we have calculated the den 1 and the den 2. Den 2 is equal y squared, summation of y squared. Okay, we have calculated that one, y square sum. Y square sum, after that minus, then summation of y squared. Summation of y is available, y sum. So here variable y sum. Summation of y sum square. Okay, that means y sum into y sum. Y sum multiplied by y sum. After that, divide it by n. N means 12. Divide it by n. Okay. Now what we have to do? Now we have the den 1 and den 2. Okay, this is the den 1 and this is the den 2. Now what we have to do? The original denominator, original den, that means den is equal square root of den 1 multiplied by square root of den 2. Square root of den 1 multiplied by square root of den 2. Or you can use the multiplication of den 1 into den 1, then square root also equal. I think you know the mathematics, I think. Now, according to this example, so this is den 1. This is den 2. Okay. Then den is equal square root of den 1 multiplied by square root of den 2. Okay. I think this is equal den 1 multiplied by den 2, then whole 1 square root. I think this is equal. I think you did the maths. Okay. This one is equals, no? According to the mathematical rules, square root of den multiplied square root of den 1 multiplied by square root of den 2 is equal den 1 multiplied by den 2 whole 1 square root. I think both ones are equal. For those who did the mathematics for A level, please confirm whether this one is correct or not in the mathematical equation. Den 1, square root of den 1. That means for this same example, that means let's say square root of x into square root of y is equal x into y square root. Is that correct? Both one? Because I also have no idea about this mathematical equation. Those who did the mathematics for A level, can you confirm whether these two equations are equal or not? Yes or no? No idea. Okay, then use this one. Then 1 into square root of, yeah, both ones are equal, no? Then means you can either take the square root of den 1 and multiply it by square root of den 2, or otherwise den 1 multiplied by den 2, then take the whole square root. Both ones are correct. Okay, then what we can do, the den is equal, so we have to take the square root. I think it is not easy to take the square root without taking the math.header file. So therefore I include math.header file. Okay, then I will take the square root. How to get the square root? I can't remember the function sqrt, no? Yeah, sqrt. Square root of den 1. Square root of den 1 multiplied by square root of den 2. Okay, otherwise you can use the den is equal square root of den 1 multiplied by den 2. Both these equations are correct. I think yes, no? You also confirm that one. You can use either this way or this way. Okay. So here I will take this one. Therefore, I ignore this one. Okay, now I have the denominator and the numerator also available. Therefore, what we can do is R value. Okay, so declare a variable called R. Okay, then we can calculate the R is equal. So numerator divide by the denominator. Numerator we have already calculated. Numerator calculated. Divide by denominator we have already calculated. Okay, then shall we print that R value, printf? Let's say R equal percentage, it is floating point value, no? Let's say percentage long float or f value and slash n and R. Let's check that R value. What is that R value? Run this program. This R is given this minus 0.809392. Okay, all of you get this value or any different value? Did you try this one? Your own, did you get those values? Okay, here the correlation coefficient R always lies between the -1 to 1. Okay, it is between the -1 to 1. Okay, however, it is the in between value. Okay, all of you get this one when you upload the answers to the Moodle. Did you take any different value? I don't know that. I don't know whether I did the mistake or not. I think this value may be correct. Okay, then what we can do, we can put this equation. Okay, how to take the equation? Before going to the equation, you have to calculate the byx. Okay, there is another one equation for the byx. We calculate the byx. So let's say byx. Okay, how to calculate the byx? Summation of x into y. Okay, we already calculated that one. Here we can see summation of x into y. It is already here. And here, it is here. That means you know this is the numerator in the previous one. Previous numerator in here also. Okay. Then what you have to do? Numerator divide by what is this value? Square root of x squared, you can see. So not square root, summation of x squared minus summation of x whole one squared divided by n. So this is, I think you already remember, this is denominator 1. We already calculated. This is den 1. Then do we need to calculate this one again? No. Then byx is equal. What is the byx? Numerator divided by denominator 1. Okay. But here no square root available. Okay. Therefore, do not take the square root. Just take the denominator 1 without square root. Okay. So it is very easy. We already have the values. Byx is equal numerator divided by denominator 1. Then byx is equal numerator divided by denominator 1. Any questions? Then we have the byx value also. Then we can show this equation to the user. Okay, that y minus y bar equal byx times x minus x bar. Byx we have calculated. So what we can do, let's say printf. Let's take regression equation. Equation, let's say eqn, regression equation eqn, equation of y on x is, okay, then what you can do, the next line, let's say print. Next line I print y minus y bar. I think it's better copy this one. Okay, it is no need to put that one. We can print it in the same line. No? Is y minus y bar equal dyx times x minus x bar. Okay. Okay, now you know the byx value. Okay, y is the variable. You can put the y as it is. Y bar. What does it mean by y bar? You know, y bar is the mean value of the y. That means mean value of this y. That will take the summation of all y value and divide by 12. That is the mean value. Okay, now here you have to calculate the y. I think we already calculated that one, no? Summation of y. Yeah, here we have calculated summation of y. No? So y bar, let's say take the y bar, declare a variable called y bar and the x bar. And calculate the y bar. You know y bar is summation of y divided by number of values. Summation of y is, I think we already put this one as here, y sum. Y sum, summation of y value divided by 12. That is the y bar. Y bar කියන්නේ මොකද්ද මේ මේකේ තියෙන values වල එකතුව 12න් බෙදලා ගන්න. හරි? values ටික එකතුවක් මෙතන දැම්මම ගත්තට මේ තියෙන්නේ. Summation of y already calculated. It is in a variable y bar. Then x bar, x sum, summation of x value divided by n. N mean 12. Okay, now you can put that values to here. Okay, then how to put that values? Y minus y bar, instead of y bar, we can put this y bar variable. How to put this one? You can erase this one. Instead of, you can use percentage LF or percentage F. Let's say 0.2 values, 0.2 to the 2 decimal places. Percentage 0.2 LF, and the x bar percentage 0.2 LF. Here y bar, here x bar, and the byx value we already calculated here. Byx also, let's say it is for the 3 decimal places, 0.3 LF. If you want, you can use for the 2 decimal places. Okay, now pass that value. You know x, y minus y bar. First one is y bar. Y bar, comma. Next one is, this is byx. Pass byx, comma. Last one is x minus x bar. This is x bar. Okay, now this is the equation. So let's run this program and check the equation. Okay, regression equation of y on x is y minus y bar. Y bar is 1.88. I don't know whether it is correct or not. If it is a mistake, let me know. And byx, this is the byx value. It is minus 0.987. I don't know whether the value is correct or not. If it is, if you got different value, let me know. And x minus x bar, that means mean value of x is x bar here. Okay, now this is the regression equation. Okay, by looking at this equation, you can predict the unknown y values if you have the x values here. It helps to predict in unknown y values for the x values. Okay, here you know the x1, 2, the 3 is not available. So suppose that you need to predict what is the y value for the x when the x is 3. Then simply put this one to this equation. Okay, that means you have to calculate the y value. X value is 3. So put the 3 to the here. Then 3 minus this one and take the y. You know how to solve the equations, no? Then find the y value. The සිංහලෙන් කියනවා නම් පුළුවන් ද හොයන්න දැන් x 3ට ආගයක් මෙතන දීලා නැහැ නේ අපිට x 3 වෙද්දි කීයද කියලා. අපිට දැන් ප්‍රෙඩික්ට් කරන්න පුළුවන් x 3 වෙද්දි මොන වගේ එකක් එයිද කියලා. මෙතනට 3 දාන්න. මෙතනට 3 ආදේශ කරාට පස්සේ මේ y යුක්ත කරලා ගන්න. මැස් කරපු අය දන්නවනේ ඔක්කොම කොහොමද කරන්න කියලා. y යුක්ත කරාන් පස්සේ මේක එහා පැත්තට යනවා. ඒතර වැලියු එකක් එනවා y වලට. ඒතර ඒක තමයි prediction value එක y. So that is the prediction y value. Okay, however, the question doesn't ask to find the predict the y values, just give the equation as it is. Okay, I don't know whether these values are correct according to the my algorithm, so according to the my code I written here. All of you got this one, these values, yes or no? Did I make any mistakes? Okay, I think these values may be correct. Okay. If the other student also got this one, I think this may be correct. අනිත් අයට මේ උත්තරම ආවිල්ලා නැහැ. ඒ කියන්නේ මේ හදපු විදිහ හරි. Okay, any questions up to here? No question. Then shall we, what are the other questions you need to solve? I think one student asked the question number 5. Question number, yeah, Basnayaka. Can you explain the Basnayaka BMGD? Did you ask this one? That means write a C program to find the average of array elements. Yes or no? Are you there? Okay. Okay, now you need to find, write a C program to find the average of array element. Use the separate function. Okay, now what we have to do that you have to calculate the average of array element using a separate function. Okay, how to do this one? Okay, now I will erase this part. Okay, I do not need this maths.header file. Then write a separate function to find the average of array element. Okay, it's not mentioned that array is an integer array or floating or whatever the one. Let's take integer array. Okay, then void, let's say, find average AVG. Find AVG or whatever the one. Here you have to pass the array. Here you have to pass an array. Let's say int ARR. Okay, and you know, we cannot find the array size by taking the array element because this is act as a pointer. Therefore, you have to pass the size of the array as a separate parameter. Okay, I told you this one in the previous lab session. Let's say int size. Okay, now what we have to do? Write a C program to find the average of element. Now let's see that after finding the average, we need to return that average to the caller. Okay, then return type is not the void. Return type average can be floating point value. Okay, therefore return type can be float or double. Okay, you may use the float or you may use the double. Okay, now you can calculate the average. First declare a variable double AVG. Initially it is 0. Now what we have to do? Each array element you have to get the summation, and after that summation you have divided by the size. So here declare another variable called summation. Initially it is 0. For int I equals 0, I less than I equals 0, I less than size, and I plus plus. Then what you can do, take a summation one by one. That means summation is equal existing summation plus that array I location. Okay, take the array I location and take it to summation. Now you have the summation of all the array elements. Okay, now how to find the average? You know, average is equal summation value divided by number of element. Number of element is in the size variable. Okay, now you have the average, that is the value. You can return that value. Return average. Okay, now you wrote a particular function to find the average. Okay, now you have to put the function prototype, copy this one and put it to the here and semicolon. Inside the main function, what you can do, you can declare an array and pass it to the here and find the average value. If you want, you can ask the user to enter the array elements, or otherwise you can hard code the values. Let's say my value is int x. Let's say 5 values. Array size is 5. Say 1, 2, 3, 4, 5. Okay, now what you can do, you can find the average value, declare a variable called answer. The answer is average value. What you can do, you can call this method. How to call this method? You can use find average, find avg. You have to pass the array. Here, my array is x. You have to pass the integer array, therefore x, and number of elements, size. Size is 5. Okay, now you have the answer. You can print that one to the user. Print average of 5 values is percentage LF / N. Okay, sorry, not the integer value. Here I put the integer value. The return type is double. Therefore, this should be a double. Return type answer, the returning value of this one is a double value. Therefore, you have declared a double type value called answer and put that answer variable to the here. Okay, now you can run this program. Average of 5 values is 6.4. So I don't know whether it is correct. I think assume that is correct. 6.4. Any questions? This is how you can calculate the average value. Any questions, or do I need to explain any other parts of the previous tutorial? Yes or no? Then shall we move to the next one? If you don't have any questions regarding the previous one, we can move to the next today's tutorial. No questions. Okay. And there is a question from the previous one. Previous one, that mean you mean lab session 7. Return value as Fibonacci, question number 5. Write a C program to. Can you explain the 6th question also? Okay, before going to the 6th question, one student asked, write a C program to receive the number of terms and return the Fibonacci series. You mean the previously I explained this one, that in the previous week I explained this question without returning. Okay, the number of series available, that means there are several numbers to be printed. Okay, then what you can do, let's do this one again. Then now you learn the arrays, no, that now you can return that array. Okay, now this question, write a C program to receive the number of term. Let's say you know the Fibonacci number. 0th Fibonacci number is 0, first Fibonacci number is 1. Here and onwards, you have to add the previous 2 terms. Okay, then you can calculate the Fibonacci number series. Okay, now you have to, this question asks to return the Fibonacci series. Okay, the previous week, I told you how to display that value without returning. Okay. Let's erase this one. let's declare a function called Fibo in term. You have to pass the term, and this will print the Fibonacci series. Okay. I think you can remember that how to do this kind of example that in the previous one. So if you are not wish to speak, mute your mic. So previous one, I told you how to display the Fibonacci series when you are passing the term to the here. So what you can do that you know that if the term equal 0, that means when the term is 0, the value is 0. Just print the value. Okay, here also I am going to print that value. Later on, I will return that value. Okay, printf 0. Okay, and the else, if term is equal 1, if the term equal 1, you know it is 0 and first term you need to print. That means 0 space 1. I am doing this one a little bit fast because I already taught you that how to do this one. And the else mean you know that 0th term is 0, first term is 1, that means 0 and 1 you need to print, and the second and onwards you have to calculate. Okay, how to calculate that one? First you have to print the 0 and 1 because you have to hard code that one because they are fixed. 0 and 1. Then the 2 and onwards, that means 4 in I equal 2 and I less than or equal term. After that I plus plus. Then what you can do, than or equal term and I plus plus. Start from 2 until the user given term. What you have to do, you know that Fibonacci series are coming from 0th Fibonacci number is 0. First Fibonacci number is 1. Second Fibonacci number is adding the previous 2. 0 plus 1 is 1. Third Fibonacci number adding 2 previous, that means 2. Fourth Fibonacci number 2 plus 1, that means 3. Fifth one 3 plus 2, that means 5. Sixth 5 plus 3, 8. Seventh 5 plus 8, that means 13. 8 plus 1, 8 plus 13, that means 21. Likewise 9. 3 plus 1 is 4. 2 plus 1 is 34. Likewise, the Fibonacci series are going on. Okay, now what we have to do, we have to print that values. Now when the end is 2, you have to calculate. Let's say Fibonacci value is, let's declare a variable to calculate that one, int Fibonacci value. Okay, and as well as the previous 2 terms. Let's say previous 2 terms are A and B, A comma B. Okay, you know initially A is 0, B is 1. If I use that one in a different color. This is A, this is B, and this is the Fibonacci number F. Okay, you know F is equal, how to take the F? F is 1. How to calculate this F? Adding previous 2 terms, A plus B. A plus B is the F. So here you can calculate inside the for loop, F is equal A plus B. Okay, then what you can do, let's just print the Fibonacci value, printf %d and space, and print that F value, Fibonacci number. Okay, then what you have to do, then you have to print the third Fibonacci number. Okay, that means when you print the third Fibonacci number, that F should come to the here, and B should come to the here, and A should come to the here. Okay, when the F come to the here, the B should come to the Fth position, and A should come to the Bth position. The F එක මෙතනට එනකොට B එක එන්න ඕන F හිටිය තැනට, A එක එන්න ඕන B හිටිය තැනට. Okay, now what you can do when you go to the F to the next position, you can identify that A should come to the Bth position. That means A equal B. Okay, and the B should come to the Fth position. The B is equal F. Okay, now what you can do that yeah, use the eraser. A come to the here, B come to the here, F is here. Now I erase this one. Now you shift the values. Therefore, now A is here, B is here, F is here. Okay, now F value should be 2. How to calculate the 2? Add the previous 2, A plus B. Okay, then again print. And after that, go to the next locations. Okay, then what you can do in the main you have to put this one as a prototype to the here. Then here, let's say printf. Let's say fifth, how to print that one? Let's say Fibonacci series up to, let's say up to 8 term. That means 0, 1, 1, 2, 3, 5, 8, 13, 21 should be printed up to term 8/n. Okay, then you can call this one Fibo and pass the 8. You have to print up to the 8 term. So then you can run this program. What happened? Sorry, I put percentage D 0, 1. And after that, what happened? If what is the mistake I did here? Yeah, int A, B, and F. Okay, initially I think I forget to put the A is 0 and B is 1. No? Okay, initially A is 0, B is 1. This is hard-coded value. No? A is 0, B is 1. Now I think it's correct. Yeah, okay. That is the mistake I done. Initial values we have to put A is 0, B is 1. Then up to the 8th term, 0, 1, 2, 3, 4, 5, 6, 7, 8. You can see 0, 1, 1, 2, 3, 5, 8 here. 0, 1, 1, 2, 3, 5, 8, 13, 21. Okay, if you want to print up to the 9th term, let's say up to the 9, and here 9, and print that values. Okay, up to 34. Okay, now I have already taught you this one in the previous lab session also. Okay, now I am going to change this one, return this value to the caller. That means here the caller is the main program, but always the caller is not the main program. It can be another program, it can be another function also, but here the caller is the main program. Okay, now instead of printing this values, the question asks to return that Fibonacci series. So here you can see there are so many numbers to be returned. Okay, so can we put the return value as int here? Then what happens? Int means only one value you can print. So if you put the int here, then only one value. That means either 1 or 2 or 5 or whatever, only one value. Then what you have to do? So in such a situation, now you need to return a series of values. That means more than one value. That means you need to return an array. Okay, how to return an array? Remember that when you are declaring an array in the main program, for an example, let's say you declare an array int arr, let's say size 3. Let's say those are the values. Okay, now when you are doing this kind of one, when you are declaring this kind of array, actually what happened in the main memory, I already taught you this kind of thing in the previous lab session also. So there is a memory locations available. So here I draw the memory locations. Likewise, memory locations available. Each memory location, you know, there is a memory address available. Okay, I told you that memory location AB1, AB2, likewise. Here I put the memory location as 1000. Starting memory location, this is 1000 and this is 1001. The consecutive memory locations comes in the consecutive manner. Okay, consecutive way 1000, 1001, 1002, 1003, 1004, 1005, 1006, 1007, 1008, 1009, likewise, the numbers are there. So then what we have to do, let's suppose you print integer values 4, 5, and 6. There are 3 locations. Okay, you know integer take 4 bytes. Okay, each memory location required 1 byte. Okay, since you need to hold 4, you need 4 bytes. Okay, that means 1, 2, 3, 4. Okay, up to here, it is the array 0th location. Array 0th location. Second one, that when you need to store the second value, that means array first location, again you need 4 bytes. That means array first location. Likewise, array second location, those values are there. Okay, and remember that array 0th location. So usually when you take the array 0th location, what is the memory address? It hold the first one, 1000. Because you can't hold the 3 values, no? So it hold the first location, that means 1000. And the array 1, it hold the 1004. Okay, although it is 1000, since this is integer, computer know it is starting, if it is starting from 1000, it should be end from 1003 because there should be 4 values. So now what happened when you are doing this kind of ARR, when you are declaring ARR and ARR is the array name, here array 0th location, ARR 0th location, ARR first location, ARR second location, likewise those things are available. ARR 0th location hold 1000 memory address. Ignore the consecutive, what are the other 3 addresses available. And ARR 1, that means 1004. And ARR 3 should be, sorry, ARR 2 should be 1008. Likewise, the memories are allocated. Then what happened? Actually, those are the memory addresses. Okay, that means this is the AND ARR, AND ARR, AND ARR. Memory address of ARR 0 is 1000. Memory address of ARR 1 is 1004. Memory address of ARR 2 is 1008. And remember that if you are declaring this kind of array, array is act as a pointer. Now this ARR is the whole array. It is act as a pointer. It holds the address of the first location. That means 1000. ARR hold the address of the first location. ARR 0th location. Okay, that means 1000. That means and ARR 0 is equal to the ARR. By default, ARR is equal to the and ARR 0th location. Okay, this is not required for this one, but you have to remember this kind of one in order to return an array. Okay, now you know ARR, this is the ARR array. Actually, it is a pointer. It's hold the memory address of the first location of the array. That means ARR 0. So ARR is act as a pointer. Okay, that means ARR holds this kind of memory address. Okay, remember that that on your mind. Now what I am going to do, instead of this, I need to, instead of printing these values, I need to save this one inside an array. Okay. For an example, let's take here what happened. The Fibonacci numbers 9. Okay. If you enter Fibonacci number 9, how many numbers will be printed? If the enter term is 9, how many numbers will be printed? Tell me, how many numbers do you have to print? If the input term is 9, how many numbers you need to print? Count this one. 9 numbers. Is it correct? 9 numbers? How many numbers here are available? If the term is 9, how many values you have to print? Here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 numbers you have to print because it is start from 0. Okay, if the term is, if you enter the 9, you have to print 10 numbers. So then now what we have to do, we have to return these 10 numbers. Then what you have to do, you have to declare an array of 10 elements. If the term is 9, declare array of 10 elements. If the term is 5, then declare an array of 6 elements. Okay. So here I declare an array int ARR. The size is term plus 1. Term plus 1. Okay, because you have to print additional 1 number because starting from 0. Now what we have to do, instead of printing these values, what you have to do, you have to assign that values to the array location. දැන් මේ print කරනවා වෙනකොට මොකද කරන්න තියෙන්නේ? මේ print කරනවා වෙනුවට මේ array location වලට ඒ values ටික දාන්න. දාලා ඉවරලා ඒක return කරන main program එක. So what you have to do, instead of printing, now I remove this print line, you have to use array 0th location is 0. Okay. Instead of printing 0 and 1, what you have to do, array 0th location is 0 and array first location is 1. Okay, now I erase this one. Here also, what you have to do, instead of printing, you can copy and paste it here. Instead of printing 0 and 1, you can assign that value to the array location. Okay, and each for loop, instead of printing, what you have to do, you have to assign that value to the array location. Okay, that means 0 and 1 values already assigned, and second and onwards you need to assign that value. Then instead of printing array 0 and 1 assign, second and onward. 2 is equal that f value. Put that f value to the 2. When the I is 3, array 3 should be f. When the I is 4, the array fourth location should be f. So therefore, instead of hard coding this one, here I use array I location is equal f. Okay, now I erase this one. It's not required to print. Okay, then what happens? This for loop declare an array of term plus 1 and assign the numbers, these numbers to that array. After that, what you have to do? You have to return this array. Okay, how to return this array? Now you need that part I taught you previously. Okay, when you are declaring this kind of array, ARR or whatever the one, this array is holding the memory address. Okay, this ARR actually it is a pointer. It is an integer pointer holding the memory address. Okay, then when you are returning that value also, you have to return what? Actually, you have to return the memory address. නැත්තර return කරනවා කියලා මොකද්ද කරන්න වෙන්නේ? array එකක් return කරනවා කියන්නේ point එකක් return කරනවා තේරුණා. So the meaning of returning an array is you are returning a pointer. That means you are returning the memory address. Therefore, return is not an integer. It is a integer. It is an integer pointer. So how to declare a pointer? It is int star. Int star means now instead of returning the value, you are returning the memory address called 1000 or whatever the one. Okay, so here also you have to put int star. Now you are returning an memory address. Okay, now what we can do is now you are going to return that such kind of memory address. So in the main program, what you have to do, you have to, when you are calling this for Fibonacci 9, you have to take that memory address to a variable. Okay, that means int x is equal this kind of one. Okay, since this is returning an memory address, you cannot hold it to a normal variable. How to hold a memory address? You need another pointer. That means int star x. You can put the star near to the int or near to the x. Both are correct. Now star x is a pointer. Okay, you put it to the this what do you call x pointer. Okay, now I erase this array. Okay, now your values are available in such a array. You have the first memory address. දැන් මේ වගේ array එකක තියෙන values ටික ඇවිල්ලා තියෙනවා. ඒකේ පළවෙනි memory address එක ඔයා ළඟ තියෙනවා. You have the first memory address. Okay, then what you can do, if you want to print these values, you can write a for loop. Now this x is act as an array. Okay, but the size is unknown. Okay, but you know size should be 9 plus 1. හරි, දැන් මේකේ values තියෙනවා අපි දන්නේ කොච්චරක් තියෙනවද කියලා. හරි, ඔය නමුත් අපි මෙතනින් දන්නවා පාස් කරේ 9 හින්දා 9ට එකක් එකතු කරලා 10ක් තමයි return වෙන්නේ. Okay, the memory address is available, therefore you know the size of this one is term plus 1. Okay, let's take int term. Let's say int n. N is initially 9. You pass the 9 into the here. Then you have to write a for loop which start from int I equals 0 and I less than or equal. There are how many values available? N values, n plus 1 values available. That means it should be less than or equal n plus 1. Less than n plus 1. Okay, therefore you can use less than or equal n. That is also correct. 0 to n. Then n value එකක් ගන්නකොට මොකද එකක් වැඩිපුර එන්නේ. then I plus plus. Okay, now remember that this X is act as an array. Okay. So now what you can do, you can print the values one by one. That means percentage D, put a space, and suppose that X is an array, you can use X I location. When you put the Xi location, it automatically, if the I is 0, if the array is, that means the memory address of this one is 1000, it print the values of the 1000. When the I is 2, it is not the 1001. When I is 2, it automatically jump to the 1004 because this is an integer array. දැන් කම්පියුටර් එක දන්නවා මෙතන i එක බිඳු වුණාම මේ 1000 එකෙන් පටන් ගන්න 4 දිග දෙක තමයි පෙන්නන්න ඕනේ කියලා. i එක 2 වෙනකොට ඒ ඔටෝමැටික් පයින්නවා 1004 එකට. Okay, that is how the arrays happen. But don't worry, you will learn those things when you come to the pointers. Okay, now this pointer is act as an array. So you can print those values from here. Now when you print that values, sorry, I forget to return the values. Here it just print the garbage value. So here I need to return that value to that array. We have defined that array. After you doing everything, you have to return that array, ARR. ARR is a pointer now, because I told you arrays act as a pointer. Okay. Therefore, you can return the memory address. Now you can call this one. Okay, now you can see the values has been printed as it is. And there was a question. So can we use a method to return 2D? Can we use that method to return 2D array? Yeah, actually, return the 2D array. I will check and let you know. I think that one is not possible from this kind of pointer. If you want to return the 2D array, then you have to pass it as a parameter. Then you can return that one, I think. So I'll explain that one also using 1D array. That means instead of returning, you can rewrite this one as an input parameter. Okay, how to do this one? So this is a one way of returning an array as a return value. Return value that means as a pointer. You can return this array as a pointer and you can capture it from here. And there is another way. Instead of returning this kind of one, let's say this is void. And here also void. And here I do not return an array. Instead of returning an array, I pass that array as a another parameter. Okay, let's say int ARR. Okay. Then what you can do, then you do not, it is not required to declare this kind of one. So here I copy this prototype and paste it here. Okay, now the array declaration is not required because it is passed as a parameter. Then you can erase this one. Now what you can do, you have this parameter value. Then for the array location, you are going to set that value. Okay, I told you arrays act as a pointer. Therefore, if you are passing this one, it is always passed by reference. Okay, arrays always pass by reference. Array values you can pass, sorry, that means array locations you can pass it by values. But if you are passing the whole array, it is always passed by reference. For an example, let's say you have this kind of array available. Let's say ARR. Let's say my ARR. These are the values. Let's say 6, 9, 2, minus 7, 5, 31, 2. Okay. Now, suppose that you need to pass this array to a function, then you have to pass the array memory address. That means here 1000, and if it is integer array 1000, and this is 1004, and this is 1000 because there are another consecutive 3 memory addresses available. Second one start from 1004, here 1008, 1012, likewise values are available. Here you have to pass the 1000. Okay, when you are passing, it is a memory address. If you are passing the array, always it is passed by reference. But if you want, you can pass a particular value. That means you are passing array. This is 0th location, this is first location. Now this is passed by value. If you use the and, then pass by reference. මේ value එක value එකක් pass කරනවා නම් pass by value ගන්නත් පුළුවන්, pass by reference ගන්නත් පුළුවන්. මේ and එක දාලා. But if you are passing the entire array, it is always passed by reference. Okay. Now what happened? Now when you are putting this kind of one, if you are passing such kind of array, it is passed by reference. Then what you can do? You can declare an array instead of this x. I erase this one. Let's say int x. The size is 9 plus 1. That means n plus 1. That means 10. Then what you can do? You can pass that x to the here. Okay, when you are passing x, it is passed by reference. That means you are passing the memory address of x. That means you are passing the x 0th location, memory address of x 0th location. මේ මෙතන x කියන්නේ ඇත්තට x 0th location එකේ memory address එක. ඒක තමයි මෙතනට pass කරන්නේ. So when you are passing this one, the function can access all the array elements. It can hold these values. Okay, it can assign the values to the array elements. Okay, then what you can do, the x value, after you pass it, the values has been assigned by this function. When you are printing the assigned value. So when you run this program, here you can see the same output. So this is another way of doing this one. Any questions up to here? Shall we move to the today's one? I think I have done 1.5 hours. Okay, I have only half an hour remaining. Okay, multi-dimensional arrays. Okay, before going to this multi-dimensional arrays, do you have any questions with the previous lab session? Sorry, not the previous, the lab sheets of the previous one. Any questions? Okay, today I will do this one, and if you have any question, you can ask it from the next lab session. Okay, multi-dimensional arrays. Okay, what does it mean by a multi-dimensional array? Using C programming, it is possible to create an array that contains other arrays. That means one array can contain another array. Okay, what happens usually when you are creating this kind of array, x is equal 10 or whatever the one, there are 10 integer values available, only 10 values. But when you are coming from the multi-dimensional array, the array contains another arrays. Okay, that means looks like, let's say you declare this kind of array, 0, 1, 2, 3. Inside here, instead of 10, 5 or whatever the values, it can hold another array. It holds the memory address of another array. That is, we call the multi-dimensional array. We can visualize it using the 2D array. That means when you are declaring it is as a 2D array, we call it is a 2D, that means a 2-dimensional array. Sorry, not only 2-dimensional array, you can go for the 3, 4, likewise many dimensional arrays. Okay, but here in your syllabus, up to 2-dimensional arrays are enough. Okay, it is possible to contain that will contain other arrays. The term multidimensional array refers to such kind of array. Take this kind of instance. Double x34. Okay, what does it mean by this 3, 4? 3 mean there are 3 arrays. Okay, there are 3 arrays. Each array has 4 elements. 4 elements mean it is another array. For an example, here 3 mean there are 3 arrays. X3. 3 mean there are 3 array. Here 4 mean each array has 4 elements. Each array has 4 elements. 1, 2, 3, 4. That is the meaning of multi-dimensional array. That means 2-dimensional array. Okay, in this context, in this context, X is an array that has 2 dimensions. Okay, the array has the capacity of 12 different elements. One way of the visualize of this array has 3 tables with 3 rows and 4 columns. Okay, we can visualize that multi-dimensional array. If it is 3 and 4, there are 3 rows. Each row has 4 columns. Okay. The locations we can access, if the array name is X, you can access this one as X00 location. This one X01 location. This one X02 location. This one X03 location. The second row starts from X is equal 1. Okay, X10 location, X11 location, X12 location, X13 location. And the last row, third row, X20, X21, X22, and X23. This is how you can access the array locations. Okay, initializing 2-dimensional arrays. Okay, when initializing 2-dimensional arrays, it is possible to specify the values enclosed in the brackets for each row. Okay, the following is an initialization of 2-dimensional array. Okay, here 3, 4. So here integer type 3, 4. There are 3 arrays. Each one has 4 elements. That means this is 3 array. This is 1 array, 2 second array. This is third array. I think you can understand this one properly. X3 means there are 3 arrays. Okay, this is first array, this is second array, this is third array. Okay, each array has 4 elements. That means 0, 1, 2, 3. Each has 4 elements. 4, 5, 6, 7. 4 elements. 8, 9, 10, 11. 4 elements. Okay, so this is how you can initialize. Okay, for an example, if you don't understand this one properly, I can rewrite this one as int x3, 4 is equal, within the bracket, you have to put first one, the first array, another curly brace. What are the values? 0, 1, 2, 3. 0, 1, 2, 3. You have to separate by commas. And the second array, you have to put another comma. This is the second array. The values are 4, 5, 6, 7. 4, 5, 6, 7. You have to separate it by commas. And the last array, again, curly braces, you have to separate here. 8, 9, 10, 11. 8, 9, 10, 11. You have to separate by commas. Okay, this is the way I visualize it in a different way. That means this is the starting curly brace. That means this one. This is the ending curly brace. That means this one. And this is the first starting curly brace, ending curly brace. That means here this one and this one. And here second array starting and ending. That means this one and this one. The third array starting and ending curly braces. This one and this one. Okay, now I think you guys can understand this one properly. The nested braces, which the point to the row that is to be written. Wait a minute. Okay. That point to be written are not required. The nested braces, that means here, for an example, the starting and ending curly brace is enough. The middle curly braces are optional. That means when the මේකයි විතරක් තිබ්බනම් ඇති මැද තියෙන curly braces අවශ්‍ය නැහැ. That means each array you have to enclose the curly braces now. That each array enclosing that part is optional. That means you can rewrite that one as the starting curly brace and ending curly brace. Values you can assign 0, 1, 2, 3, 0, 1, 2, 3, and 4, 5, 6, 7, 4, 5, 6, 7. After that, 8, 9, 10, 11. 8, 9, 10, 11. It automatically assigns the values in that way, mentioned in the previous one here. Okay, and alternatively, you might initialize the values as shown below. That means I told you by accessing the array location. That means the 0th location, this one you can access as x00. This is x01. This is x02. This is x03. This is x10. This is x11, 12, 13. Likewise, here you can put x00 location is equal 8. That means 00 location mean here. That 0 will be replaced by the 8. A, so here it is a different one. The previously, this is x value. Suppose that this is not A, this is x value. Then x12 location. 1, 2 location means this is 0, this is 1. 2 location means this is 0, this is 1, 2. So this is the 1, 2 location. That means 6. Then 6 will be replaced by 27. But here it is mentioned as A. Suppose that this is not A, this is X. Then this will be replaced. Okay, then accessing the two-dimensional array elements. How to access? The same way you can use the access by putting the array locations, like in this way. Okay, subscript or the array rows and column indexes are used to locate the specific element in the two-dimensional array. We are going to use the array column, row and column indexes. Okay, for an example, so here 0 and 5, this is a one way of initializing the value. And after you initialize, if you want to print the value, 0, 0 location. 0, 0 location means this is the 0th array. Here 0 means this 1 and 2. Here 0 means only 1. That means 0, 0 means 1. And 3, 1 location. 3, 1 means third array, first element. What is the third array? This is the 0th array. This is the first array. This is the second array. And this is the third array. 7 and 8 it is the third array. Okay, third array, first element. You know this is the third array. What is the first element? 7 is 0th element. 8 is the first element. Okay, then it print the 8. Okay. Otherwise, you can, if you want, you can print every value using a nested for loop. Okay, you know there are 5 arrays available. Therefore, outer for loop should control how many rows available. In I is equal 0, I less than 5, I plus plus. In the inner for loop, each one has 2 elements. Start from 0, less than 2. Then you can print the array locations in that way. IJ location. Okay, now let's do some exercises available here. What is the time? Now it is 7:46. Okay. Write a C program to create multidimensional array of size 3 by 3. 3 by 3 mean 3 rows and 3 columns. That means there are 3 arrays. Each array contains 3 elements. Okay. To initialize the following values. Then update the program to print values as a matrix. So you have to assign this value to the 3 by 3 multidimensional array and print it like this kind of matrix. That means you cannot print the borders. Borders cannot be printed like this kind of squares. Instead of borders, you can print 2, 3, 5 likewise. So how to do this one? So here I erase this one. Question asks to create a multi-dimensional array of size 3 by 3. Okay, now I am going to create, let's say, int ARR 3 by 3. 3, 3. Okay, now assign the values. How to assign the values? You can use the equal. And there are how many arrays? 1, 2, 3. There are 3 arrays available. So we can use the curly braces. First, this is for the first array, comma, second array, comma, third array. However, that middle curly braces are optional. You can omit that one. Okay, now I come to first one. The first one we have 2, 3, 5. So here you can use 2, 3, 5. You have to separate by commas. The second one, 1, 8, 9. 1, 8, 9. Separate by commas. The last one, 6, 7, 0. Okay. You can put values in this way, or otherwise, I think you can display it like in this way. 2, 3, 5, 1, 8, 9, 7, 6, 0. You can use whatever the way you like. If you want, you can use in this way in one line, or otherwise you can put this one in this way. First array, second array, and third array. Okay, now what you have to do? We have to print that values. The question now to print the values as a matrix. Print it in that way. So how to print that one? You need to write for loops for int I equals 0, I less than how many rows available? There are first one, 3 rows available. Okay, that means here 1, 2, 3. Therefore, out of for loop control the how many rows available. හැමසම එළියේ තියෙන for loop එක control කරන්න මේ වගේ rows කීයක් තියෙනවද කියන එක. inner for loop එක control කරන්න columns කීයක් තියෙනවද කියන එක. Okay, now you know there are 3 rows available. Then less than 3, because 0, 1, 2 and I plus plus. Then inner for loop. Let's say int j equals 0, j less than j control, that means inner for loop control how many elements available in each array. There are 3 elements. Less than 3 and j plus plus. Okay. Suppose that this is not the 3 by 3. Suppose that this is 5 by 4. Suppose that this is 5 by 4 array. Then 5 means there are 5 rows available. That means 5 arrays available. That 5 controlled by the outer for loop. Therefore, this is less than 5. Okay. Inner for loop control how many elements in each array. Okay, here it is mentioned there are 4 elements in each array. Okay, therefore here you have to use the 4. Okay, this is how you can control. But here in the question, it is mentioned as 3 by 3. Here 3, here 3. Then the both outer for loop also 3 and inner for loop also 3. Okay, now what you can do, you can print those values. How to print? You can use the printf percentage %d and put a space to print the next value and comma. Then what you can do, I0, j is 0, then you can print the array 0, 0 location. That means ij location. Okay, this is how you can print the values. Okay, now run this program and check what happened. Here you can see the print the values 235. Here 235, 189, 189 and 670. 670. But it print in a one line, not like this kind of matrix. Okay, then what you have to do? Remember that once you print one array, that mean you know there are 3 arrays available. No? Each array has 3 elements. When you print the first array, this one, before going to the next one, you have to go to the next line. That means the inner for loop print arrays one by one. The inner for loop first print 235. After that 189. Okay. So mute your mic if you are not wish to speak. Okay. Now once the inner for loop is finished, that means when the I is 0, it print 235. After that, it go to the I is 1. Okay, I is 1 means the second array. Before come to the second array, what you have to do, once you complete the first part, that 235, you must go to the next line. Printf put /n. That means go to the next line. Okay, it should be outside of the inner for loop, but inside the outer for loop. Outer for loop එක ඇතුලේ තියෙන්න ඕන නමුත් inner for loop එක එළියේ. Inner for loop එක මේ ටික print කරාට පස්සේ තමයි මෙයා යන්නේ. Okay, now when you print this one, you can see it's like a matrix now. 235, 189, 670. Okay, however, you cannot print this kind of borders, but you can print the values in this way. Okay, any questions? I have 5 minutes. Then try to second one. Update the above program to get the summation of each row. Okay, now you have to get the summation of each row. That means 235, what is the summation? 189, what is the summation? 670, what is the summation? Okay, then what you can do? You can, let's say, put a comment. Summation of each row. Then what you can do, you can write a for loop. If you want, you can use the existing for loop. So when you are, sometimes you may confuse, therefore I copy this one and paste it here. Now what we are going to do, now I want to take the summation of each row. Okay, in order to get the summation, you have to declare a variable. Okay, each row, that means here there is a one summation, and there's another summation, there's another summation. There are 3 summations available. Then what you have to do, you have to declare 3 variables. Okay, either you can declare 3 variables, else that means either this one, or you can declare another array to hold the summation. Okay, that means you can declare integer type, let's say summation of row, sum row size is 3. Okay. Then what you can do, initially you can put values are 0, 0, 0. Initially the summations are 0. Then what you can do, you can calculate the summation. How to calculate summation? When you are writing this kind of for loop, instead of printing, what you have to do, when the I is 0, when the I is 0 mean this one, take a summation of this one. So you can take this one to the here. That means summation of row I location. That means initially I is 0. That means summation of row 0th location. That means this location is equal existing summation of row I location plus whatever the values here. That means 0, 0 location. That means array 0, 0 location. That means ij location. 0, 0 location means ij location. Okay. Sorry. Plus. Okay, you can rewrite this one, summation of I plus equal this one. That is also correct. I mean, you can use either this way, or otherwise I comment this line. Otherwise, you can rewrite this one as summation of row I location plus equal array ij location. The short form. The short form is this one. You can use this short form or otherwise this way. Okay, now we have put the summation values to this one. Okay, now this printf/n is not required. Okay, then what you can do after this for loop is complete, then you can print the values in the summation of row. This is since this is a 1D array, that means one dimensional array, the one for loop is enough. For if I is equal 0, I less than whatever the 3, there are 3 values available, I less than 3, then I plus plus. Then what you can do, you can print the values, printf sum of row 1 is equal, let's say value is 23, is 23. Okay, then /n. Okay, now you know we cannot hard code this 1 and 23. 1, how to calculate the 1? You can use a percentage D. 1 is the 0 plus 1. That means I plus 1. Here we can use I plus 1. I plus 1. And the 23 also an integer value, percentage D. How to get the 23? 23 means it is in this summation of row 0th location. Summation of row 0th location. That means I location. Okay, you can print in that way. So you can run this one. Here, summation of row 1 is 10. That means row 1 means this one. 2 plus 3 is 5. 5 plus 5 is 10. And the summation of row 2, 1 plus 8 is 9. 9 plus 9 is 18. Summation of row 3, 6 plus 7 is 13. 13 plus 0 is 13. Okay. You can take a summation using this one, or inside here also you can calculate. That means rather than putting this one, you can put this one inside the when you are printing this value, you can put in the next line and put the summation of row before the for loop. That is also possible. That means it is not required to put the for loop again here. You can use the existing for loop to calculate the summation of row also. Okay. Now it is 8 o'clock. Okay, I will do the third question also. Update the above program to get the summation of diagonal values. Diagonal values mean there are two diagonal values available. That means this is one diagonal, this is another diagonal. Okay, let's say this is D1 and this is let's say this is D1 and this is D2. Two diagonal values. Okay, now you need to print the summation of this one. Okay, what you can do? You can again come to this one. Take the summation of diagonal values. Summation of diagonal values. So we need the two, we have two diagonal values, then we can declare an array of two elements, or otherwise, since there are two elements, I will declare two integer type variables. Int t1, comma d2. Okay. Now what we can do, I will use this for loop again, copy and paste it here. Okay, that means it is not required to copy and paste. You can use the existing for loop. Here I use a different for loop for this one. Now I need to get the diagonal values. Okay, how to get the diagonal values? According to this example, D1 is equal here. That means the 2. What is the 2? You know the value start from, I will use different color. This is 0th row, first row, second row. This is 0th column, first column. The red color is good for here. 0, 1, 2, 0, 1, 2. 0th row, first row, second row. 0th column, first column, second column. Okay, now 2 means 0, 0 location. This is 0, 0 location. 8 means 1, 1 location. And this 0 means 2, 2 location. Location. That means D1 is equal 0, 0 location. That means array 0, 0, 0 location plus array 1, 1 location plus array 2, 2 location. Okay. Now how to get this one? Array 0, 0 location. 0, 0 location, 1, 1 location, and 2, 2 location. So now, instead of writing this one, I need to check whether 0, 0, 1, 1, 2, 2. That means 0, 0 means both I and j values are equal. Here. If I explain this one again, here 0, 0 means, here 0 means this is I value. This is I value, this is j value. This is I value, this is j value. This is I value, this is j value. Okay, here you can say 0, 0 mean I and j equal. 1, 1 mean I and j equal. 2, 2 again I and j equal. Okay, you know when the I and j are equal, it is a diagonal value. So what you can do, if I equal j, it is a diagonal value. Then you can take a summation. Then D1 is equal existing D1 plus array ij location. If the I and j are equal, then we can take this one. D1 is this one. Likewise, calculate the D2. How to calculate the D2? So D2 means, so this is D1, this is D2. Okay, D2. How to calculate the D2? D2 means array, here 5, D2. This one is 0, 2 location. Here the 0th row, second column. 0, 2 location plus array. Here 8 means 1, 1 location. Here 1 and 1. 1 location plus 6 is 2, 0 location. 2, 0. Okay. Now what is the pattern? Here this is I, this is J. This is I, this is J. This is I, this is J. Okay, here how to identify? Here I and J are equal. Here I and J equal. Here I and J equal. What happened? Here I0, J2. I1, J1. I2, J0. Now what is the pattern you can identify? Here you can identify summation of I and J is 0, 2. Summation of I and J 0 plus 2 is 2. Here summation of I and J 1 plus 1 is 2. Here summation of I and J 2 plus 0. It is 2. Here you can identify always summation of I and J is 2. So that is the pattern. That means if the I plus J is equal to the 2, it is belong to the D2 diagonal. Can I and J, I එකයි J එකයි එකතුව දෙකයි නම් ඒ කියන්නේ මේක D2 diagonal එකේ diagonal එකට අදාළ value එක. Okay, then you can calculate the D2 value. Okay, here from the if condition you calculate the D1 and you can write another if condition. If I plus J equal 2. Okay, I plus J equal to, that is belong to the D2 diagonal. Then D2 is equal existing D2 plus array IJ location. Okay, then what you can do after the for loop complete, you can print the values printf. Sum of diagonal 1 is percentage D slash N. Let's say it is D1, diagonal 1. Likewise, copy and paste, print the second diagonal value. Summation of second diagonal value, diagonal 2 is D2. Okay, now you can run this program. What happened here? I think so we have to initially put the D1 as 0 and the D2 as 0. Because initially there are no values, no, we can't use the garbage value. Initially put the D1 and D2 as 0. After that, calculate. Okay, now check whether diagonal values are correct or not. That first diagonal value is D1. That means 6 plus 8 is 13. 13 plus 6. Am I correct that diagonal value? Diagonal 1 is 10. 6 plus 13. 13 plus 6 is 19. Yeah, it is diagonal 2. Yeah. 6 plus 8 plus 6. Sorry, 5 plus 8 plus 6. It is diagonal 2. That is 19. And the other diagonal, 2 plus 8 is 10. 10 plus 0, it is 10. So, mute your mic if you are not wish to speak. Okay, 8 plus 2 is 10. 10 plus 0 is 10. So, that is the other diagonal value, diagonal 1 and diagonal 2. Okay, any questions up to here? So this is a diagonal. You have to try the other three elements. So other three questions, because the time is up. Now it is 8:11. Okay, I think you can you know how to multiply the matrices. Okay, did you? I think there is a mathematics subject. You know how to multiply the matrices. So if we have this kind of two matrices, that means one two-dimensional array and another two-dimensional array, you have to multiply this matrix. I think you know how to multiply the matrices. That means when you multiply, this one should be multiplied with this one. That rows should be multiplied with the columns in the other matrix. Left side rows should be multiplied with the columns in the other side. That means 2 should be multiplied by 3. Okay, 2 plus, that means 2 into 3. 2 into 3. Plus, then second one should multiply with 4. 2 into 4. Plus, third one should multiply with the third one. 3 into 3. I am not again and again. Tamil RM, are you there? 215. Mute. So when you are attending to the lectures, behave yourself. If you are not wish to speak, you have to mute your mind. Okay. Then 2 into 3 and 2 into 4 and 3 into 3. Okay. And this is the answer for this one. That means you have to take this one and put it to the output first location, 23. Okay, you know, 2 into 3 is 6, plus 2 into 4 is 8, plus 3 into 3 is 9. 9 plus 8 is 17, 17 plus 6 is 23. That is how the 23 comes to the here. Okay, likewise, again 2 to 3, sorry, again this 2 to 3 should be multiplied by 5 to 2. That means I'm going to do this one. Again, 2 to 3 should be multiplied with the second column. First column you multiplied and put it to the here, then the second column. That means 2 into 5. And 2 into 2. Plus 3 into 2. Okay. This value should comes to the second location. That means 2 into 5 is 10, plus 2 into 2 is 4, plus 2 into 3 is 6. 6 plus 4 is 10, 10 plus 10 is 20. That's how it's happened. Again, you have to do 2, 2, 3 multiplied with the last column. Last column, that means this one. That means 2 multiplied by 7 plus 2 multiplied by 1 plus 3 multiplied by 1. Then this value should be come to the here. 2 into 7, 14. 2 into 1, 2 plus 3 into 1 is 3. Okay, 19. The value is there. Okay, this is the first row appear here. Likewise, you have to Now first row is over. Then you have to multiply with the second row. So I will erase this one. Then you have to take the second row, multiply it with the first column. That means 3 into 3, 2 into 4, 4 into 3. This value should be appear in here as 29. Again, this one should multiply with the second column and should appear in here. And again, this one should multiply by the last column and should appear here. And when you come to the last column, should multiply, sorry, last row should multiply with the first column and appear here. Last column should multiply with the middle one, should appear here. Last one should multiply with the last one, should appear here. This is the output available. Okay, now you have to check another condition when you are multiplying the matrices. You know that when you are making the multiplication, when you multiply this one with here, okay, when you multiply with here, 2 should multiply with 3 and 2 should multiply with 4 and 3 should multiply with 3. Okay, what happens if you have another value, that means another row here? Let's say here 9 to 7. Likewise, this kind of, that means this is 3 by 3. This is 4 by 3. This is 3 by 3. This is 4 by 3. Can you multiply? Now what happened? 2 to 3 should multiply with the first column. Then how to multiply? 2 into 3 and 2 into 4 and 3 into 3. But there is a 9 available. 9 into what? Is there any value available? No. Then this multiplication cannot be completed. This multiplication is incorrect. You can't do this kind of multiplication. I think there is a question again. It can't multiply. Yeah, you know, this kind of one cannot be multiplied. In order to multiply this kind of matrices, you have to check the condition. That means number of columns, that means here number of columns in the left side should be equal to the number of rows in the right side. Okay, how many columns you have? Column 1, column 2, and column 3. Number of columns, column 1, column 2, column 3 should be equal to the row 1, row 2, and row 3 should be equal to the number of rows. Left side column should be equal to the right side rows. Otherwise, the matrix cannot be multiplied. Okay. Here the example is 3 by 3. But when you are multiplying, the user will ask to enter the, you have to ask the user to, first one, left side is which kind of one? 3 by 3 or 3 by 4 or whatever the one. And the right side also, which kind of one? You have to check the left side number of columns is equal to the right side number of rows. If it is not equal, display to the user, the matrix cannot be multiplied. Otherwise, you can do the multiplication and give this answer. Okay, now I think you guys can understand this one. Okay, since I have taken over the time, now it's 8:20. Now I am going to wind up the class. Okay, before conclude the lab session, do you have any questions? I will upload the link to this one. Upload link for this. Let's say test or whatever the one. Today is October 26th. So you can upload it on October 31st, no? 26, you have 4 days. Okay, you have 5 days and 3 hours. Upload your answers to the lab session 9. Okay, any questions up to here before wind up the class? If you don't have any question, I can conclude the lab session. No questions. Okay, seems to be you don't have any questions. Therefore, I conclude the lab session. Thank you for the participation.
answer